silicon boom and brittle minds, the 1980s. The promise. In the 1980s, the world believed the digital future had finally arrived. Wall Street was booming, computers were entering the home, and governments were pouring billions into a radical promise. Machines that could think like human experts. They called them expert systems, the XCON era. Systems like XCON were deployed by massive corporations to automatically configure computer parts using thousands of strict, hard-coded if-then rules. Japan launched its massive fifth-generation computer project, spending hundreds of millions to build machines that could converse and reason in human language. AI was suddenly a billion-dollar enterprise. But beneath the hype, a fatal flaw was hiding. The silent winters and deep blue, 1987 to 2000s. The crash. By 1987, the bubble burst. The specialized, expensive hardware built for AI couldn't compete with cheaper, faster general computers from Apple and IBM. The expert systems were too brittle they couldn't adapt to new data. The promises had been too grand and the delivery too small. Investors panicked. Funding disappeared. Artificial intelligence entered its second, coldest AI winter. For a decade, the word AI became a career killer in computer science, the awakening. But in the shadows of the winter, the philosophy changed. Instead of trying to program human rules into computers, researchers asked, what if we let machines learn from raw data? In 1997, the world got a terrifying wake-up call. IBM's Deep Blue defeated the reigning world chess champion, Garry Kasparov. It wasn't true human-like thinking, it was pure brute force mathematical computation. But it proved one thing: the machines were getting smarter. The Deep Learning Awakening, 2006 to 2021. The three pillars. In the mid-2000s, three unstoppable forces collided, triggering the modern AI revolution. First, big data. The internet gave us billions of images and texts to train models on. Second, GPUs, graphics cards designed for video games, turned out to be perfect for running massive parallel mathematical matrices. And third, deep learning. Led by pioneers like Geoffrey Hinton, neural networks modeled after the human brain finally had the data and horsepower they needed to thrive. Defeating the masters. In 2012, an architecture called AlexNet shattered image recognition records. In 2016, Google DeepMind's AlphaGo defeated the world champion of Go, a game with more possible moves than there are atoms in the observable universe. Then came 2017. Google researchers published a paper introducing the Transformer architecture. It was a master key designed to understand the context of data like never before. The fuse was officially lit. The generative explosion and the agentic era, 2022 to till date. The public awakened. In late 2022, the floodgates opened. ChatGPT was released to the public, reaching 100 million users faster than any technology in human history. AI was no longer hidden in research labs or corporate back-end systems. It was in the hands of everyone. Within months, generative AI evolved from clunky paragraphs to flawlessly generating full-color images, synthetic audio, and cinematic videos from a single sentence. The agentic present. And that brings us to today. We have officially crossed the threshold from generative AI to agentic AI. Today's models don't just answer questions, they plan workflows, use software tools, correct their own mistakes, and reason through complex logic autonomously. In less than half a century, AI has evolved from static if-then code blocks into an autonomous digital workforce. The revolution isn't coming anymore. It's already here. And it's only just beginning. But this is only where the real mystery begins. Hit subscribe, turn on notifications, and I will see you in part 2.